Hello and welcome, everyone. This is Diego Lopez moderating for MIT Horizon. Thank you all so much for joining us today. We're lucky to have Lynette Kucsma here to discuss 3D printing techniques that can be used for food. Lynette Kucsma is the co-founder and chief marketing officer of Natural Machines, the makers of Foodini, the first 3D food printer and IoT kitchen appliance made to contribute to a healthy eating lifestyle. Lynette is a senior marketing professional with international experience working with companies ranging from startups to Fortune 500s. Thanks so much for joining us today, Lynette, and I will hand things over to you.
Fantastic. So my name is Lynette. I am a co-founder of Natural Machines, and it's a pleasure to be here today. So we're going to be talking about how additive manufacturing is changing the future of food, or as we like to simply call it, 3D food printing. So to give a bit of history about us, we started in November 2012, so we're now 8 years old. We've been doing this for quite a while. At Natural Machines, we create innovative kitchen solutions, and 3D food printing is the first product we actually put out on the market. We call our 3D food printer Foodini. We are headquartered in Barcelona, Spain, where I'm talking to you from right now. We also have offices in New York and Beijing, and we have customers around the world. So let's dive right into it. And I wanted to start by showing you what 3D food printing is the way we do it. So we actually allow people to use their own fresh real ingredients. You would prepare those ingredients for your meal, put the ingredients in a capsule, put the capsule inside Foodini, pick your print, it will start printing, and when your print is done, you can either finish it off with other foods or just eat it straight away, depending on what you're actually making. So some people might call this concept a bit crazy for 3D printing food, but it's actually not that crazy because if you think about it, if you eat anything from a food manufacturer, so anything you buy packaged in a supermarket, you're practically already eating 3D printed food. We just don't call it that. So a food manufacturer takes food, they push it through machines, they shape it, and they form it. We've taken that exact same concept and we created a kitchen appliance that sits on your kitchen counter. But the big difference is you can use your own fresh ingredients and you can customize your food so you become the manufacturer. And in essence, food manufacturers are actually talking to us about the future of food and how this impacts what we currently buy in the supermarket today. So when you're buying something in the supermarket, it's fairly limited on the variety of what you can get. There's only so many different flavors, so many different product lines. But what producers are looking to do is potentially, let's say, deconstruct their foods that they offer today in the supermarket and give you the capability to reconstruct them in a 3D food printer. So that way you can make it much more customized for the individual rather than selling products that are for the masses as you see in the supermarket. And this concept of customizing foods is actually not that new. It's starting in the beverage industry, actually. So you have things like Coca-Cola Freestyle, which is in restaurants and food service locations. And that actually allows you to choose your different soda flavors and flavor profiles and create your own individual unique drink. And in home, you have SodaStream that does the same thing. So you can create your own custom sodas, your own custom sparkling beverages. So it's starting in the world of food to actually customize things to the individual with the beverages. Now the next step is food, and 3D food printing is helping with that. So to take a closer look at 3D food printing, when people see it, like this print you see here, it is additive manufacturing. It goes layer by layer. We build it up as extrusion printing. And some people see this and say, well, you know, that's pretty much automated piping bags. That's what you're doing. You're automating a piping technique. And in some cases, that is true. That's a good analogy. But when we think about piping bags, we tend to think about chocolate, icing, decorating cakes or decorating cookies or any type of bakery environment where they actually use piping to do decoration. An example of how we do that, where this analogy works very well, is Christmas cookies. So we printed these last week and we decorated them with Foodini. And as you can see, we're taking the icings one by one, like an automated piping bag, if you will. The machine is actually automatically exchanging the icing. So that's done automatically. There's no manual process there to actually change the different icing colors or the different flavors. And when you look at this, you can see like, oh yeah, somebody could pipe that manually, or in our case, we automated it. And this is not something we're only doing in our offices in a closed environment. This is actually out in the field. So this is a photo of a supermarket in Greece. And on the photo on the left there, that's Foodini. It's kind of hard to see because you're seeing it from the back. But what's not hard to see is that this is in the middle of a supermarket. So they have it in their chocolate specialty bar area, where, as you can see on the photo on the right there, they're customizing messages for individuals on demand. So the advantage to having a 3D food printer here to do this is that they don't have to train specialized people to do piping. Piping's not as easy as it looks. It is a skill, and you have to have good handwriting, good technique. But here, anybody who works in their chocolate bar can be trained up very quickly as to how to do this type of decoration with Foodini and make it automatic. But the reason why we don't like to use the piping bag analogy in all cases is because we don't think about all foods with piping bags. So like our round O cereals or rectangular breakfast bars or pizza, we don't think about piping bags with those foods. Same here with these nachos or tortilla chips. So these were actually 3D printed or 2D printed. They're more 2D, they're very flat. But that's actually a very good reason to use a 3D food printer, because to make these types of flat foods or flat crackers, it's very difficult to do for a lot of people, including myself. Doughs are hard to work with. So we printed these and they're very customized. So this is something I actually did. This is white corn flour, no oil, salt, and spices. That's it. No additives, no preservatives. But try to find that combination in the supermarket. You're not going to. So this is where the customization of food starts coming in, where we can actually do things with our own fresh ingredients and customize it for us. So on the flip side, we go to some of the more designer foods, let's say. So the more visually impressive ones. So this is from a top chef here in Barcelona. This is actually freshly made guacamole. And a lot of chefs in Horeca, hotels, restaurants, and catering, and in the hospitality industry, our plate decorations and food presentations is super important. And it's actually important just in general because we all judge our food based on what it looks like, whether we consciously acknowledge that or not. So in this case, I wanted to do something fancy. And some people say, well, you could do this with a food mold, but not really. Because if you were using a food mold for this, you would have to freeze the guacamole to unmold it. And then, what's the point of making fresh guacamole if you have to freeze it and then unfreeze it just to get it designed? So here we can actually use freshly made guacamole without freezing it. And of course, you cannot do this by hand or by using food piping. It's very a specific design, so it's very difficult to do. And food presentation is not just for adults, it's for kids as well. So this is one of my photos from a couple years back now, actually, when my kids were younger, and I was trying to encourage them to eat a spinach quiche, and they just weren't having any of it. They claimed they didn't like it, which is fine. Not everybody likes every food. But I did an experiment, and I took that same exact recipe, and 2 weeks later, I printed it in the shape of dinosaurs. And my dinosaurs became extinct very quickly. My kids loved it, just based on a food presentation angle. It's the same recipe, but food presentation is important, and it does help kids eat healthier and explore other foods. So 3D food printing doesn't have to be all about chocolate or icing or cookies. It can be very healthy foods as well. Some of the industries that are really into 3D food printing these days are the alt protein and clean meat companies. So here is a print we did with 3F Bio and their Abunda mycoprotein product. So we're printing it because when you 3D print these alt proteins, it adds a different element in the texture. So there's a lot of alt protein companies and clean meat companies that are trying to mimic real meats and get this whole chicken breast or whole steak and get the right texture to it. So 3D food printing definitely helps with that. So we're working with a lot of companies with that. And as you can see, the texture is pretty convincing. And a lot of that has to do with the actual 3D printing of the product. We don't create the formulations ourselves. We can help with that, but that's not our business. That's their business. Our business is the 3D printer specialty aspects. Another industry that's very interested in 3D food printing today is hospitals and senior living centers. So this is a dish created for people with dysphagia. people with dysphagia have trouble swallowing, so they need to eat soft foods. Now with Foodini, you do not have to use purees to print all the time. That's a fallacy in the industry. We can actually print textures because we have different nozzle sizes. But in this particular market case with this use, it needs to be pureed food. So for lack of a better term, the people who have dysphagia, what they tend to eat normally is a bowl full of mush, which, as you can imagine, becomes very unappetizing and uninteresting after a while, or actually very quickly. So what we do is we work with hospitals and senior living centers to actually take those fresh foods and we print them. So here, oops, that didn't run the video. There we go. So here you can see one of our clients is printing the food individually, and then they're going to put it together on a plate later, but you can also print the whole plate because we can do multiple capsules and exchanges. But we're basically printing meat, potatoes, and roasted carrots here. And as you can see, the visual impression is much more stronger and much more appetizing than if you were going to get just this in a plain bowl, just in one bowl. Here's another dysphagia print just to show you how realistic it can get. This is a serving of peas. Now, some people that work in the dysphagia space, they also use food molds to create the food, but again, you need to freeze the ingredients and unfreeze them to demold them and then unfreeze them to eat. And in the case of peas, the reason why we showed this particular photo is because when you're using a food mold for peas, it tends to look like child's play food, you know, the plastic foods you might get in a toy kitchen, which doesn't look very realistic and doesn't look very appetizing. But here you can see it looks very appetizing. So the 3D food printer brings it up a big level. And finally, sustainability is a big area around 3D food printing. So these are two example dishes of sustainability dishes and zero waste. The dish on the left is from a chef in Iceland. Iceland has a large seafood industry, obviously, and they have a lot of cutoffs from fillets and a lot of byproduct and a lot of scraps from fish. They're all actually perfectly good foods, but they're just this ugly concept until it's printed. So then it looks visually attractive and people want to eat it and keep it in the food chain. The dish on the right is from a 2-star Michelin restaurant here in Barcelona. And they created an optical illusion dish with carrot cream. They used ugly carrots, and those carrots were in the refrigerator that needed to be used. They were perfectly fine, but they were on the verge of not being fine. So the chefs made this dish out of it. Now, so this is all about zero waste and using all foods, but we're not saying that 3D food printing is the solution for food waste. There's many solutions for food waste. It's a big problem. We need a lot of solutions. But there's only so many smoothies we can make out of ugly fruits and only so many soups we can make out of ugly veg. So this is giving people another option as to what to do with those foods with different textures and different presentations. So we can use up more food that's perfectly fine to eat. So up until actually currently, the market for 3D food printing, it's a B2B play. So it's all professional kitchens right now, whether that's hotels, restaurants, chefs. We work with schools, we work with research centers, we work with hospitals, senior living centers, and of course we work with food manufacturers and food service providers. So it's all the professional kitchens right now. But our vision is that in 10 to 15 years, 3D food printing will become a common kitchen appliance in home kitchens as well. And the reason for that is, again, so people can customize their foods, use more fresh, real ingredients, become much less reliant on packaged food that's been sitting on the shelf for several months or years. So we know from all of our market research that to get into the home market, we needed to cook the food as well. You may recall from the earlier video, the alt protein video, that we actually printed it and we pan fried it. In the future, we'll be able to cook it as well. So we actually developed laser cooking inside the device. So yet another innovative solution, but it's actually a very healthy solution. You can use much less oil and water when you're cooking. It's sustainable because it uses much less energy. It uses 90% less energy than an oven. And our taste testing, and this is coming out very positive, people are preferring foods cooked with lasers because it retains the moisture and it's just a much better experience. Now, we've been working on this technology since about a year after we started the company. So for about 7 years now, we kept it secret for the first couple of years. And now we just started talking about it recently because we're in the industrialization phase of this. So once you get this into your homes, this becomes a multifunctional device where you can print and or cook. So we don't believe in the future that you'll need an oven, a stove, a microwave, a 3D food printer that cooks. You're going to start seeing consolidation of kitchen appliances, and each of those appliances needs to earn their space and be multifunctional. So that's what we were building towards. And that's about it with my time. That kind of gave the tip of the iceberg overview of 3D food printing and the future of food, tapping into professional kitchens, producers, and what we think is going to happen with consumers. As you can see, there's a lot of different variety of foods you can create, from the extravagant to the normal shapes, if you will. And I hope you can see from this presentation that we see the 3D food printing future as being used to be able to create sustainable, customized, and precisely cooked food. So 3D food printing will be changing the future of food for the better. Thank you very much.
All right. Thank you so much, Lynette. That was absolutely fascinating. Thanks so much for sharing that all with us. So our first question here is asking, what food products currently aren't possible with this technology? And do you think that this will advance to create them soon?
So taking the first part of that question, we can print pretty much anything. Now, it's not necessarily the types of food or the ingredients that are the issue or the bottleneck right now, it's the textures. So I did say we do not have to print solely purees, but as an example, you cannot just take an entire carrot and put it in the device and start printing. You have to process that carrot to a certain extent. Now that carrot can have chunks in it. It doesn't have to be a totally smooth puree. It depends on the nozzle size you're using. But we do see the future where that will widen. But also keep in mind when you're cooking a lot of foods, the texture changes naturally. Like if you're making a bread dough and you cook it, that's very different than the dough, right? So your food does change as you cook it. And the second part of the question was, can you repeat that, please?
Oh, sorry. And for anything that's not yet possible, do you think that this technology will advance soon in order to create that?
Yes. Again, like we have clients across the world right now. So people in Asia print very different ingredients than Europe versus the Americas. So right now you can print a very wide amount of foods. But again, I see that texture is really the area that's really going to open up in the future.
Very cool. And our next question is asking, is cleaning a challenge for these 3D printers? And can that sanitation process be automated?
So I will say that Foodini is the only 3D food printer on the market that's FCC and CE certified. So cleaning is part of that. I'm partially laughing because every time my engineers develop something on Foodini, and even for the past 8 years, every time they do something, I'm like, how easy is that to clean? Because everybody hates those kitchen appliances that are useful, but very hard to clean. I'm looking at the juicers, right? So nobody wants that kitchen appliance in their kitchen. So I'm constantly striving to make food easy to clean, and it is. So basically the capsules that you saw, they're stainless steel. So that means you can wash them by hand or put them in the dishwasher. They don't retain scent, they don't retain color, they don't retain flavor. The dish in Foodini is very similar to a microwave dish. So it's the glass Pyrex. So again, that can be dishwasher safe. The walls are like the inside of a microwave, so easy to wipe down. So everything we do with this, we want to make sure that it's an easy to clean kitchen appliance, because again, nobody wants that kitchen appliance that is a nightmare to clean after, even though it might be an easy kitchen appliance to do something.
Right, that makes sense. And the next question is asking, how will these technologies change the way food is manufactured at a large scale? And do you think it could reduce the cost of food going forward?
So large scale, we compare 3D food printing to the food manufacturers that already exist, right? So that's the large scale. Now we're taking it to the extreme opposite, which is localized manufacturing, which is what any 3D printer does, whether it's plastic or metal or food, is localized manufacturing. Now there's that in-between space between the big manufacturer and the localized manufacturing that we can scale up to do more volume. And we built Foodini to do that in the future. But, we are only 8 years old. We're still a small company, so you have to focus. So we decided to focus on that individual unit. So right now, we actually have clients that if they do higher volume, we have a client the other day that just got 6 Foodinis in their bakery. So they're just adding more devices to do different things. But in the future, we could scale up. As for the cost of food, uh, it's we say it's the equivalent, but it really depends on what you're printing. So the idea behind this, especially for consumers, is to get people to eat more fresh foods that are more sustainable, eat, not get the package of food that's already pre-made and has additives and preservatives, but you can actually replicate a lot of that on a 3D food printer and control the ingredients and use fresher ingredients. So the cost of that, those tortilla chips, cost is probably the same as buying a bag, because I was using corn flour and just salt and spices. It may have even been cheaper. And of course, I had less waste because I didn't have the packaging waste. But it really depends on what you're printing. But ultimately, this is all about, keeping it so it's not a more expensive proposition. And it's also a healthier proposition that's more under your control.
All right. Excellent. Very cool. And so what are some of the considerations for food manufacturers when deciding whether or not to switch to 3D printed foods or to continue with traditional preparation methods?
So I don't think the food manufacturers are going to shut down their factories anytime soon and shift totally to 3D printing of food. The analogy is kind of the same with what they do with what we do. It's just more localized. I do know some food manufacturers now are using 3D printing in terms of plastic or metal to test out new molds or, new part pieces for their factory to test out new foods. But I can safely say that a number of major manufacturers have come to us talking about how this is going to impact them in the future. So they do see, like Coca-Cola did with that example I showed about how Coca-Cola is now enabling people to actually customize their sodas. Food manufacturers are interested in that as well. So it's very expensive to add a new product line to a food manufacturer's factory line. Even if you're adding new flavors, there's only so many you can do. Like a Oreo cookie probably has 20, 30 varieties. They have quite a lot. But that's still, if you can actually deconstruct that cookie and reconstruct it in your home with different flavors, different ingredients, you can get hundreds or thousands of variations, which just isn't possible in a big food factory. So they're looking at it, will this happen overnight? No, there's no such thing as an overnight success. Even, the Nespresso coffee machines or the K-Cups in the States, that took literally 30 years to get to an overnight success. We don't think it's going to take that long because people are much more into tech and adopting tech a lot faster these days, and it's coming down in price and what have you. But I can say that food manufacturers are very interested in this, and they're currently with their R&D labs trying to figure out what this future is going to look like.
All right, very cool. And on a more technical note, what range of nozzle sizes and diameters are you using? And are these nozzle diameters dynamically changeable, like during the printing process, or do they kind of have to be manually swapped?
So each capsule has its own nozzle. So you get to control what nozzle goes on each capsule. So right now, Foodini ships with 3 standard nozzle sizes. We do 0.8 millimeter, 1.5 millimeter, and 4.0 millimeter. I realize I'm talking European measurements. That's just how we measure that. We also have other nozzle sizes available, and you can use things that are off the shelf, like Dornson nozzles, which are very small, thin nozzles. But you usually don't need to go that small with food unless you're talking about an all-protein alternative. So we don't switch the nozzles in the device itself per capsule because we don't want cross-contamination between the food. So if we have each individual capsule has its own nozzle, then when the machine is switching it, you don't have that residual or cross-contamination within the food from one nozzle to the other. But it's totally in your control. And that's another area where I see a lot of interesting things happening that we're working on. I can't talk about them in detail right now, but just in terms of different nozzle sizes and different applications, so you can get a much wider range of things you can do. But again, when you're talking about foods like even breakfast bars or what have you, use bigger nozzles for that, which also makes printing faster as well. So the bigger the nozzle size, the faster the print normally, depending on what you're doing.
Excellent. And this next question is asking, with the popularity of food delivery services on the rise, such as like Uber Eats, do you think that there's a growing market for customizable foods?
I do think there's a growing market for customizable foods. So Uber Eats and those types of food delivery programs, yes, they are on the increase. But I will also point back to even when COVID started hitting on a global scale, that one of the top things that was selling was actually a bread maker. So people are actually starting to become, even with your macro trends, more interested in what they're actually eating. Where's their food coming from? What profiles can I get with that? So part of the goal of having this as a 3D food printer is to make it easier for you to make those own foods in your home. like that tortilla chip example, I would not have made those tortilla chips if I didn't have a 3D printer. And I'm not just saying that because I own the company. I'm saying that because to make those tortilla chips without a 3D food printer is you have to have a clean workspace that's, fairly a good size. You have to roll out the dough really thin. It's a sticky type of dough for that type of nacho chip. And it's too difficult. Nobody wants to do that. But when you have a 3D food printer that can allow you to do that in a really easy fashion, where it's just making the dough, which is literally a 5-minute process, then suddenly making your own foods becomes a lot easier. And I think what happens with food delivery, again, I don't see that going away anytime soon. There's a need for food delivery in those types of markets, but I do see it shifting. There's still a big opportunity there for tools and appliances to help you make your own fresh foods faster and easier, so you might not need to rely on those food delivery services so much.
All right, excellent. That makes a lot of sense. And it looks like we have one more question here for today, and it is asking, I'm curious to learn in what countries or regions the 3D printed food technology is being most well received now.
Oh, well received. I will say our major markets are your big typical 3. So Europe, North America, and APAC, so Asia Pacific. And it's different needs in each market. So we had the globalization thing, but it's still different in each market. So I will say that Asia picks up on it faster. They're more accepting of weird technologies and checking out what they are and seeing what their uses are. So they kind of step into it faster. Europe is a bit slower moving, but more methodical in how they do it. So things are moving here in different ways. So the dysphagia market is actually bigger here, although we see that an increase in Asia as well. So it really depends on your market. And in North America, we have bakeries doing cookies and tapping into that space. We also have people looking at the dysphagia space, but they're a bit slower in the US versus the other areas we're working in. So really, there is a big difference between the regions of the world and who's doing what. So again, I will say again, because it bears repeating, that it's not an overnight thing, right? So we deliberately say 10 to 15 years in the future, 3D food printing will be common. And that sounds far away, not so far away, but it takes time to get people to understand what this is, to experience it, and to have it more into a common situation. But we do see the start of that now. As I said, Fujini's in the market already. It's not just a prototype on a sheet of paper.
All right, excellent. Well, that takes us to time for today. Lynette, thank you so much for joining us today and for sharing all of this. This was absolutely fascinating to see. And thank you all for joining us and sharing your questions. And we hope to see you all at the next event. Thanks again, Lynette. Take care.